Hi, I'm Max, and gonna be doing some tutorial here, I guess, about how to kind of juice up this little 2D game um, in DragonRuby. Add some cool like animations to it to make it look a bit nicer. Um, this is very unscripted. I have no idea how this is gonna go. I'm gonna do some live coding. I haven't really done that before. So we're just going to go through it and see what happens. So first let's talk about this little game I made. So I have this little blue guy. He follows the mouse, and there's this red enemy. There's like a boss fight is the idea of what this game could be. And you can see he follows me. He faces me at all times. And I've got a little shot. I can shoot these kind of massive projectiles. I can click and hold to like have one ready to go and then let go, and it shoots. It's got a little bit of animation now. It spins. That's kind of nice. These are all just like placeholder graphics, obviously. You'll replace them with better art in a real game, but this is what we got. So let's talk about some things to spruce up. First thing is that this shot is like not very interesting because you just kind of click and it shoots. Very common mechanic is like you have more of like a charge shot. As you charge it up, it gets bigger and more powerful, and then you let it go and it shoots. I think that would be good to have in here, so that there's a little bit more of, you know, something tactical where it's like you have to decide whether to shoot a bunch of little shots or to charge up to a big shot. So I'd like to add that. Then once we do have a charge, probably want that to have like kind of an interesting animation just so that it looks neat when you're charging things and you, I don't know, feel cool. And then lastly, I want to add a little bit more of a cooler feel to the movement. So right now the keyboard is just like directly hooked up to this player movement. You can see it's like very kind of mechanical, very choppy movement. And also the boss like literally is perfectly following my position. It's because that's just how it's coded. So that also looks kind of weird. This again, it's this very like artificial mechanical look to it. So it'd be nice if that had like more of a feel, like some kind of physical feeling to it. So that's the stuff that I'm gonna add, and I'm gonna show you how to do that using some of the animation tools that I've made that are open source. So first, let's go to the code and kind of walk through this real quick. Come back to this guy later. So it's not terribly long, 150 lines. Most of it is just in this tick method. So just setting up a bunch of player state here, like we've got the size of the player, how far the shot starts in front of them, how fast it moves. I put in some idea here about charging, where like maybe this is like the minimum power and the maximum power of your shot, but currently that's unused. Player speed, then the direction that the player is pointing in. If you actually care about like the actual vector from the player to the mouse, that's here as well. Then the player position, and finally we've got a shot. So this is a single like bullet entity basically. So as you're like holding down the mouse button, this is like kind of a preview bullet that is going to hover in front of the player. This rvec2 stuff, this is included in my library. This is just like a simple vector math library that actually I copied from someone else's open source Ruby, DragonRuby vector library. So that's all that is. Again, we'll get to the shot stuff later. Then we have an array of shots because you can shoot out a bunch of them. Then we have some basic stuff for the boss, radius, position, speed, and then the direction that the boss is facing. Haven't implemented boss movement yet, but whatever, that could easily be added. So first thing we do is we just use the input from the keyboard to add to the player's position. Nothing fancy there. Then, oh yeah, this I was kind of screwing around with. Actually, this probably works right now. This idea of like, oh, like maybe the boss will like kind of whack you around. So I was just made it that when you press spacebar, it kind of like shoves you in a random direction. And this will be much more interesting once we add some like physicality to the animation, because right now you can see I'm literally just kind of like jerking around randomly. So this is going to get much cooler once we add the animations. Then making the boss look at the player. make the player look at the mouse. That's what this is doing. Then if you're holding down the left mouse button, then we're setting like the player's current charge level. And currently I'm just setting it to the maximum charge. This is where we're going to add like more of a charging curve in the future. Then we've got the preview of the shot, little typo there. So here we're just saying like, okay, if the player is charging, then we're going to update the kind of like direction that the shot preview is from the player. And this is kind of like a little trick here, is like how we actually do that is we put the shot directly on the player, and then we say the shot is going to move forward at that velocity, this shot distance velocity, and then the shot just has like its own tick method to iterate itself. And so that moves the shot out so that it's at the preview distance, and then we reset its speed to 0 so that the shot will not like continue flying off in that direction. I don't know, just a little hack to get the shot to like hover in front of us when we hold the mouse button down. That's because every frame it's putting the shot directly on us, letting it move forward a little bit, and then stopping it by resetting the speed to 0. And that's that. Oh, and then, right, also transferring, this is also kind of preparing for the animation. Every frame we transfer the current start charge state from the player onto that shot. So like whatever charge level the player is at, the shot will get to. And so we can like animate the player's charge level, and this will make sure that the charge shot gets updated. And then finally, if you let go of the mouse button and we have a charge ready, then we shoot. And so here we create a duplicate of that preview shot, and then all we have to do is actually set the real speed that we want it to have and add it to our shot array, and then say that we have lost our charge now because the shot exists. And that's basically it. So the rest is just drawing stuff. So we're going to draw the player, pretty straightforward there. Then we're going to draw the boss. Then we draw this single preview shot for the player. And then here's where we're actually iterating the shots, and I'm doing like an update/cleanup all in one loop using select. So we go through the whole array and we say, okay, we want to keep all the shots that are within bounds of the screen and also update all the shots. This is what causes them to spin, this little animation, and also move. And then finally we draw all the shots that are still remaining in the array. So finally we can go to the shot thing. This is the only thing that I have a class for in this game, because like this is the only entity that I'm actually creating the boss and the player like singletons in this case. So shots have a bunch of attributes that we modify: their position, the direction they're going to move in, the rotation for the animation. Then they have a speed and a charge that we can set, and we're just loading all that up. Their tick method is just moving in the direction according to the speed. Then their rotation is just 2 degrees per frame. You can duplicate a shot. We use this when we actually like turn the preview into a real shot, and then they have a method for turning them into the appropriate sprite. So that's it. That's all the game code. And yeah, now we're going to go into doing some animation stuff. So as I said, first thing we're going to do is get this to be a charge shot. And the way we're going to do that is actually here when we're saying when the mouse is held, charge. So if you're holding the left button, currently we're just setting the charge to the player's max charge. But what we actually want to do here is we kind of want to create like an animation object. And this animation object is going to encapsulate the transition that's going to occur as we're charging. And so what we're going to use here is actually a library that I wrote, which is enumutils. And this has like a nice pattern for making animations. So this isn't even using the library, actually, this part. This is going to do just a built-in Ruby thing. So first we're going to say the args state player charge, let's call it like the charge curve or something. So this is enumerator. And what this is doing, this enumerator object, think of it like an animator. So this object is going to hold on to the state of the animation for us, and it has this yielder thing, which is going to, you can use this object to like get, to have like the animation kind of like pause between frames. So we're going to create this object, and then as part of our tick method, we're just going to tell this charge curve animation to advance. So the first thing we want to do is we want to do this increasing charge, right, from minimum to maximum. And so the simplest way to do that, this is now using my library, is using yielder run ease with an extra e. And then you give it just the duration of the animation. So let's say, I don't know, like a 1 second charge is probably nice. And then you give it a, transition function about what that should look like. And we're just going to start off with the identity, which is a linear transition. And then you give it a block, which gets the time of the, well, not the time, it's more of like the progression of the animation. So this t is going to vary from 0 to 1 as the animation progresses. And that's always the case. So if we had like a really slow charge that lasts 10 seconds, it doesn't matter. This t is still going to vary from 0 to 1, telling you the progress of the animation. So it's independent of the actual duration. All that is calculated internally. So here we can say we're going to transition over 1 second, and then we get this t value. And then all we have to say here is what we're actually going to do with this progress of the animation. So we're going to do a lerp, and we're going to say when t is 0, the minimum value of the lerp is going to be based on that minimum charge. I think that's what I called it. Yep. So the arg state player min charge, that's where we're going to start, and then we're going to end at arg state player max charge. So that's just computing a lerp between those two endpoints. And then what we want to do is we want to say args state player charge. I think that's what I called it. Yeah. So here, instead of hard coding it like we are on this line, we're going to now have the animation updated. Arg state player charge. Yes. That looks good to me. And then, so that's basically all we need for the animation, but the way that enumerators work in Ruby is they're not just kind of an ergonomics thing. By default, an enumerator like runs out, and then you'll get an exception actually when it runs out. And so we don't want that to be the case here. We want to be like, as long as you're holding the charge button, we're going to let you hold it forever. So at the end here, I'm actually just going to say yielder, actually, I don't even need to do that. I can just say loop yielder nil. And so this is just an infinite loop to say, after we're done fully charging the player, we don't need to update their charge state anymore. And then every time we can keep running this enumerator, and we're just going to say nil, doesn't really matter what this value is, like we're going to ignore it. It's just saying that, yeah, we're still running and that's fine, who cares? So that's the end of the enumerator there. So we don't need this anymore, I'm pretty sure. Yep. And now we're going to add our little update here. So now we can say if arg state player charge curve. So if we have an animation ready, then we're going to run it. And that's, you just call next. This is a built-in enumerator thing. And that just means like run this loop here for one iteration, essentially. And this is handled internally by the ease method. So that's why you don't maybe see some of the details of how that's working. So that's the gist of it. We probably have to update a few other things as well, like, so setting the direction to match the player, that's all fine. This part, as I mentioned before, this is actually exactly what we want. So our animation above is updating this variable, this charge, on the right. And here we're copying that over to the shot. So as we're animating it for the player's value, the shot's going to get updated, so everything's fine there. And then, okay, we have to update this as well. So once we fire the shot, we also want to get rid of the animation. So we'll say the charge curve is also nil, and that's going to stop this part from running because we don't want to keep like, you know, increasing their charge after they fire. So now we cross our fingers. This is where I haven't done much of the live coding. We'll see if this actually works. Okay, it didn't crash. That's nice. And it's very tiny, really tiny shot. Did I screw something up here? Say player. Min charge to max charge. Oh. Sweet. Okay, well, it's still shooting, so that's nice. So probably something is going wrong. Let's see. Now we get to do live debugging as well. So, oh, duh. So I think that's what I need. Yeah. So this is one of the trickiest things about DragonRuby in general is like when you should use or equals versus equals. So if we're holding down the mouse button, we don't want to recreate an animation every single frame. We want to say like, okay, when we've clicked the mouse button, if we don't have an animation, set an animation. And that's what or equals is going to do. So I think the problem before is that basically as I was holding down the mouse button, it was constantly restarting this animation at the minimum charge state. And so now fingers crossed. Yeah. Very nice. And so you can see if I click fast, we get all these little shots. And if I hold it down, pew, big guy. All right, so that's the first part of my animation toolkit is that ease function and kind of this code pattern of how to hook that up to an enumerator and doing things like using yield or run and loop to kind of compose pieces of an animation together. So next thing we're going to do is we want to juice up this curve because right now it's kind of boring. It just like it grows linearly. Yeah, let's make it more interesting than that. So we want it to have like kind of a cool curve to it. So how we're going to do that is using a Bezier curve. And this is where my tool actually comes in. So I'll link to this on itch. I've got this DragonRuby animation editor that I'm going to run. And this is kind of the default view, letting you edit this Bezier curve. So what we're seeing here is this preview is like showing a transition from, really it doesn't matter what the endpoints are, you can scale it however you want. You can think of it as a transition from 0 to 1 or from start to finish, whatever. And so you can see that right now the curve, like at the start, it kind of dips down below this line, then increases steeply, goes above this top line and then back. And that's what we see this animation do, right? So it kind of dips back, shoots over, and then kind of goes, overshoots its target and comes back. So as I play with this curve, I think you'll pretty quickly see that it's just like the behavior follows. You can get all kinds of interesting transitions this way. Woo! Yeah, so this is a really great general purpose tool for like just getting lots of interesting feel to your animation. So let's play around with this until we get something that like feels cool for our charge curve. And I think like gameplay wise, what you'd want is like maybe it starts off kind of slow, but then suddenly charges really fast at some point to kind of encourage you to like charge up for a little bit to get to like that sweet spot. So let's do something like we want it to be sort of slow and then maybe like that. Wow. Yeah, that looks pretty cool. I like that. So now we can Control C, and it's going to copy that code to the clipboard. So if I go over here, now we can get that right there. And this is in a separate file, so I have to load that Bezier. And so basically what this does is this call here is going to create a function and return that function. And that function is a easing function, just like identity is an easing function. So you pass it a progress from 0 to 1, and it outputs sort of a new progress that you should use instead. And so here I can just save that in a variable, and then instead of this identity, we're going to pass the Bezier curve. And that's actually all we should need to do. Again, fingers crossed, but yeah, that's the simple way you do that, because there's a couple of cool things going on here. So one is like this easing code is like designed to work with any easing function, so we're just swapping one for another, so it doesn't care. The other cool thing about this enumerator is that since it's sort of encapsulating the animation in an object, this is very efficient, because actually calculating this Bezier function is somewhat expensive, but we only have to calculate it once. Once we calculate it, it's stored in this enumerator, and then what I said before about how Ruby uses this yielder to actually like pause this in between frames. So we create it once, and then it's done. It's going, and it's just running this little loop here, frame by frame. And it doesn't have to recreate the Bezier function ever again. It just recomputes. It just plugs in these values of t into the function that we already have, and uses that to do the transition. So should be able to see that. I'll shut up now. Yeah, and you can see, yep. Yeah. So it like starts off slow and then shoots up. So that's really cool. I like that. Wow. Very nice. Okay, so that's stage one done. So next thing I want to do is I want to add a little bit more interest to the animation here, because right now it's like it's spinning, but it could be cooler. So my idea is, let me go back to the code. We've got the little shot here. I want to add just a little variation, like visual variation to it, just so it has like kind of a pulsing wiggle to it. So the idea I want to go for is like we have this wiggle, and then I'm just going to put a comment here. It's like modify wiggle somehow. And then when we draw the sprite, I'm just going to modify the radius by this wiggle. So it's going to, as we change this wiggle value, it's going to be a little larger or smaller or something like that. So I want to do that. And there are probably a bunch of different ways you could do that in DragonRuby, some more kind of straightforward than others. But like, I guess the traditional way you would do this is you could do something like, you know, if wiggle is less than 10, wiggle plus 1, something like that, else if blah, 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 blah. And you could write all this logic to like make the wiggle go in and out. I find that really confusing personally. It's like kind of hard to keep track of. I'd much rather use an abstraction that lets me just like write down what I want the wiggle to do, and the code just handles it. So again, you can use Bezier curves for this. So what we're actually going to do is here I'm going to create this wiggle animation, and guess what? It's another enumerator. And let's think about what we want this to do. So let's go back to the animation editor. And essentially what I want let's kind of not even pay attention to the curve. So at the left end of the curve, the wiggle is going to be some minimum size. And then at the right end of the curve, the wiggle is going to be its maximum. And we want to transition from the minimum to the maximum. And then we want to transition back. We want it to wiggle in and out, like symmetrically, something like that. So for that, probably if we want like a smooth transition, we would want these corners here where we're going like from minimum to maximum back to be smooth. So simple way to do that is you just line up these handles with this top line. And you can see that's the curve kind of like naturally like smoothly transitions into the corner. So then if we were to just reverse the animation, it's going to smoothly transition out of the corner as well. So here I'm going to do that. So let's just great. And something like this. It can be pretty symmetric. I think I'm okay with that. I don't know, something like that. Sure, actually maybe let's have it spend a little less time in the transition. So we see like a little more time at like the maximum and minimum. That might feel a little bit better. You can always play with these numbers. That's kind of the whole point of the tool, is it makes it really easy to play with. So we're going to make our easing function. And so now there's two stages to our animation, right? There's one where the wiggle is going to be increasing and one where the wiggle is going to be decreasing. So again, we're going to use yield or run to do that. And we're going to use ease. And what duration do we want here? Let's say like in out, maybe like twice a second. So that's going to be like 1/4 of a second increasing in size, then 1/4 of a second decreasing in size. Let's try that. And we're going to use our Bezier easing function. We get our time. And then what do we want to do here? We want to lerp. And so this is going to be, I have no idea what I want this to be. So we need to lerp from like our minimum wiggle to our maximum wiggle. That's the idea of what we're doing here. And let's go from some like negative number to a positive number. So it actually like shrinks and then gets even larger. And let's do like -7 to 7, something like that. Sure. So that's that. And then the second stage is we can do the exact same thing and we'll just lerp back from 7 to -7. And then we want that to loop forever. And this is the really nice thing about enumerators is you can write that in like the most direct way. You literally just put the whole thing in a loop. Everything is all good. And again, super efficient because the enumerator will cache this Bezier curve. So we never recompute it. We just compute it once and then it's saved for the rest of the animation. So that's, forgot the most important part, right? We don't want to just compute the wiggle value. We actually want to save it on the object. So there we go. So now we're actually changing the wiggle. And so now in our tick method, where I say modify the wiggle, well, that's encapsulated for us. So we can just say wiggle animation next, and that's going to modify the wiggle for us. Easy peasy. And that might actually be it. I think we might be done. That's the wrong thing. Whoa, no, non-float value. Sprite in tick, 157. Interesting. More exciting live debugging. Keep going to the wrong thing, 57. Oh, it's in computing the sprite. Oh yeah, you even said that. It's on line 40. Non-float value. Am I screwing up the wiggle in some way? It could be that I already have a shot in existence that doesn't have a wiggle saved. This is the other tricky part about DragonRuby. You have to be really careful about this stuff like this. I think this might be the problem, is that essentially I've already initialized a shot, which is stored in the game state. And that shot might not have wiggle set because I just added it. And so it's complaining that like that shot can't animate its wiggle. So we could try, well, no, because I really just want to replace it. I think this might just be one of those cases where I have to restart the game. I'm kind of new to DragonRuby, so I don't know like a really good way to solve this problem. But let's just try it again. Yeah, of course, it's fixed now. So that was the problem. Every now and then in DragonRuby, you just have some junk in your game state, and that can be a little bit annoying. So now, okay, the animation might be a little too dramatic. It's kind of like hard to see the charge because it's so dramatic. Okay, maybe we need to like ease that down a little bit. So nice thing here is we can just modify this animation and, again, it might not update on the preview, but let's just make this much less dramatic and hopefully that'll, yeah, much better. I don't really want to think about how to fix that right now, so I'm just going to do the lazy thing and restart the game. It's really just like the cache data in the shot preview is the annoying thing. Okay, there we go. Boo. So I think that's looking pretty good now. Especially, I like it when you're holding the shot, because then it's just like this pulsing thing. Arguably, the pulse is like a little too strong during the curve. I think a simple way to fix that would be, because the problem is we're multiplying it. It's like wiggle is treated the same as charge. So we could just make it independent. So it'd be actually just that. So we multiply the radius by this like scaling factor in the charge, and then we just add the wiggle in. And so now the wiggle is more constant. So we could do like that actually. I don't know, just gonna have to play with it until it looks cool. Sorry, keep having to make this. That's still very dramatic. But at least this way the wiggle is constant. I don't know, you can play around with it. Just gotta keep doing it. Oh, actually, that's not bad. Yeah, I like that. It's pretty subtle. Nice. Okay. Cool. Phase 2 done. So now we're going to player movement. And as you might recall, the problem here is I said like the player movement is very like rigid and mechanical. We want to give it a little bit more of like a feeling to it. So just to kind of recap, what we just did with Bezier curves and enumerators ain't gonna work here, because really the key point here is like this whole t variable, this transition from 0 to 1. Like it has a start point and an end point. That's what you need in order to do something like this. We don't have that for the player because we don't, like, where is the end point? Right? The player can move in any direction unpredictably. So it's impossible to use just a normal like easing function for that because we don't know where the player is going to try to go. How do you even model it? Well, animation tool, got you covered. So we've got the second mode, second order dynamics, which we'll switch to now, and it solves this exact problem. So what you're seeing here now is as I'm moving the mouse, this picture is following the mouse, but it's following using what's called the second order dynamic system, which basically models the behavior of an object with these three parameters, f, z, and f, well, it's technically zeta and r. And it is basically internally tracking things like the position, velocity, and acceleration of the object so that you can have this sort of like physicality to the movement. And the idea with this mode of the tool is you can just play around with these parameters and move your mouse around and also look at this curve that it's drawing to get a sense of what feel results from the parameters. So in this case, you can see like this curve, it's essentially modeling like a change to input. So the input position used to be like this value, then we changed the input value to this position, and then this black curve is telling you, well, how is the system going to respond to a change? And it says, well, it's going to kind of respond very quickly, but then overshoot, and then sort of slowly come back down and approach the target. And if I move the mouse like quickly from left to right, you'll see that's exactly what it does. The picture overshoots and then eases back. So hopefully you can understand how this curve is describing the movement here. So I can just press these F, Z, and R to edit these. So F is the frequency. So if I, add, I can make that like crazy high, and you get this like, where like really, really snappy behavior. And then Z is the damping coefficient. So if you set that to 0, actually, the system will oscillate forever. You get almost like an orbit. Usually not what you want, but technically an option. Whereas as long as I just set some value greater than 0, it will eventually slowly settle, depending on how much damping it is. So if you set like 0.9 damping, you barely see any oscillation at all. And then R is the responsiveness. So if you set 0, you'll notice there's this kind of like smooth curve up. So you get this like initially very sluggish behavior where like really takes a second to get going for R0. You can do interesting things with negative numbers where it actually like has to like kind of be like, whoa. It actually moves in the opposite direction initially, which is kind of nuts, but could be useful depending on the animations you want to go for. But anyway, we don't want that. We're doing player movement here, right? So we want it to be pretty responsive. So probably we actually want a positive R value because we want, as soon as the keyboard or whatever input the player provides, as soon as that happens, we want the player to start moving in that direction. So we don't want any lag here. So responsiveness is pretty important. We might even want to just do like 1 so that we get like a very quick response. We also probably don't want any overshoot. So like I would be wary about using like really low damping values because I think it'd be annoying to control something if they like literally move past where you're trying to move them. So I think I'm gonna probably do something like that where we could just do 1. Yeah, I think we want 1 because I think if damping is 1 or greater, then you don't get any oscillation at all, which is what we want. But I also want it to approach pretty quickly, so let's just stick at 1. And then I think now if we increase the frequency, yeah, you get like a sharper approach. That's probably way too high. That's probably too low. Maybe like 2. Let's try that. So this works similar to the other one. So now that I think I like the movement, I can do Control-C to copy this code. And now we'll see how this one's used. So what we're going to do now, this is going to be a little bit more invasive. So we used to just be tracking the player's position directly. That's not going to work anymore because how this works is everything's now separated in 2, where you have sort of a target that you're feeding into the system, and then the system tells you what value to use in the actual like game state. So we're going to split these up. So in the game, we're going to say, okay, this is now I'm going to track these variables. This is our position target. So anywhere where we want to modify the position target, we're going to use that variable. So when we're getting input from the keyboard, that's modifying the position target. Similarly, my kind of playing around code here about jolting the player, that's going to modify the position target. And then here, so now the boss is turning to look at the player. Here I don't think we want to use the position target because we want the boss to actually look at where the player is. So that's where we would want to use the output of the system. And similarly here, we're setting the player's facing to look at the mouse. For that, since this is like an aiming game, you want that to be precise. We probably want that to be the actual position as well. So let's not touch that for now. And then just double checking down here. This is similar, setting the shot preview. We want that to be directly connected to the player. And then here we're just drawing them. So actually, I think that's it. So this is kind of like the line, which is like right here is where we want to, I'm just going to say to do get the player's actual position from the system. That's what we're going to do. And so here, we're also going to need the system. And so I'm just going to call this like maybe bad variable names, but this is the target position and this is the system for the position. And so we're going to set this to the thing that I just copied. Sec_or_did stands for second order dynamics. And it needs a starting point, and we're going to say the starting point is, of course, the player position. Target is the starting position. We need to include this as a separate file. There we go. And now we've got that. So I think we can just jump right down here, and here we can say arg state player, position system. I believe the method is just called input. And this one, actually, maybe I should pull this up. Wait, where am I? Oh no, it's not an app, it's in lib. Okay, this one's a little more complicated. So let's just skip down to the update function. So update requires, surprisingly, the frame rate and the input position. So that's what we're going to do here. So as actually suggested in the comments here, this is built into DragonRuby. You almost always want to use args GTK current frame rate. So that's what we're going to use. That's GTK current frame rate. The reason why this is an option is because you might want to like do something like simulate a path. Like actually, that's what I'm doing here, where I want to like draw this response curve. That's not using the frame rate. So there you can actually plug in just like a fixed number, and you can see, you can like predict how the system will react. But if you're doing real-time stuff, you want the current frame rate. And then we need their target position. So there's going to be args state player position t. I just realized I had a typo up here. And then the last parameter here is the input velocity. So if for some reason we actually know, like, basically what this system supports is you can have both a target position and a target velocity, essentially. And you can feed both of those in, and the system will update based on those. Alternatively, you can just say, I'm not providing the input velocity, and the system will estimate it based on the change in position from the last thing you input. And that works pretty well with everything I've tested. So that's what we're going to do here. So that's our input to the system, and then that's just, oh, and I realized it's not called input at all, it's called update. And that's going to update the state of the system, but it also, crucially, outputs the actual position we should be using. So I'm just going to say player position equals. And this is a vector type, so we're just going to use that now. So everywhere that has this player position, we're going to change that to just this local variable. And I'm going to do the same thing here. Yep. And then here we've got the player position as well. Yeah, I think that's what we want. And then here, yeah, we're setting it to the player's position, so we're going to change that. And then these as well, because we're drawing the sprite at the updated position, and this is the shot and the boss. So that should be it. I think so. Again, let's all collectively cross our fingers. Oh yeah. Now this one's maybe subtle, and maybe I'm just like way too excited about this, but you can probably hear on the recording, so my keyboard is very loud, that when I let go of the mouse, for just a second, the player keeps moving. So they're kind of like sliding now. Just a little bit of a slide at the end, which feels like, again, maybe you can't see it so well in the recording, but it feels so much more natural. It doesn't feel like they're just like snapping, because there's just a little bit of lag when they're responding to my input, and also just a little bit of slide when I let go. Like there's this friction almost. But crucially, like without a whole physics engine, like if you're making a game where you don't need like fully simulated physics on everything, this is so much easier. Because like, you know, we did this with just like a couple lines of code and then basically swapping out some variables. So that's that. Yeah, I think we're done with that step. Player movement solved. So much more juicy now. So now we're going on to the last part, which is the boss. Basically same problem, that they're way too snappy. So this is going to look very similar, but with a little bit of tweaks, because it's the same kind of solution, right? We want to do the same thing where it's like the boss's direction is fully dynamic, because it's based on the player input, which is fully dynamic. So we have to use a second order system to give it this physicality, because we can't do something like an easing function. So we're just going to go back into the code and do the same sort of thing. So going back to the animation editor, for the boss, I want to give them a little bit of heft. I want them to feel like they're this big, like lumbering thing. So here I actually want to give them a little bit of springiness. So let's see if we can dial this down. Maybe that's, actually maybe that was good. Maybe even 1. There's probably different ways you could do it. We could even try R0. Oh, that's very sluggish. We probably want the boss to like respond pretty quickly to like the player moving. So let's stick with, we could try something in between. You can always play with the numbers. So let's try that. I don't know. I think it'd be cool to have the boss like a little bit off. Like you could get, this is where you could get dodging, right? If you like move quickly back to forth, the boss is gonna like, you know, miss you or something because it like takes them a little bit to respond to your movement. So something that's sluggish like this might actually be good. So I'm gonna copy that. And yeah, let's go back to the code. Let me close this. So we're gonna do a similar thing. So now we're affecting the boss's rotation. So we've got the boss's direction in radians here, and we're going to do the same thing where now this is a target direction in radians, and we're going to have a system for that, and that system is going to be this code that we just copied, and the starting is going to be the same as before. So I think that's right. Yeah, we just want the system. Yeah. And then, oh, I should have. Okay, I think luckily nothing else is called this. So similar thing that we did with the player, probably should have analyzed this first, is now we've done the split again. So instead of just having a direction, now we have a target direction and a system for updating the actual direction we're going to use, right? So we need to look through all the places where we were using direction and figure out which one should it be. Should it be the target direction or the system direction? So in particular here, the boss is rotating to look at the player. This should be the target direction, right? Because we want the target direction to be perfect, looking right at the player, and then the system is going to handle all the rest. So here we can update that. There's the player facing, that's not relevant to the boss. Oh, I forgot to test the jolt. We'll come back and do that. Oh, that's actually it. Yeah, it was very simple. So this one, we can actually, let's just do it right here so we don't forget about it. So we've updated the boss's target direction. Now we just need to update the system, basically the same way we did with the player. So we're going to say boss direction and radians equals arg state boss, what do I call it, direction system dot update. Same thing, args gtk current frame rate, arg state boss direction target in radians. That's what we want. That looks right to me. And so now we just need to use that in the right place, which is just currently only drawing the boss's sprite. Is that what I called it? Nice. Okay. So that's the boss's direction in radians, and let's see what I broke. Of course I didn't. X doesn't exist on 3.14. Of course. Of course, I forgot this. Yeah. So, right. The crucial thing here is the way I wrote the second order system is it's two-dimensional. Just because I figured that's a common use case, and that's actually the example that I saw was for a two-dimensional system. But actually, it doesn't really matter because you can do any number of dimensions because they're all independent from each other. A two-dimensional system is just two one-dimensional systems kind of bolted together. So if you want to, what we want here is a one-dimensional system because we're just tracking direction. And so you can just hack that in. I recommend hacking that in. You just make it two-dimensional. So you can just pass an array and say, here's the thing we care about, and 0, and whatever. And we'll just like never update 0, so it doesn't matter. It's very efficient code, so don't get too bent out of shape about it. So when we come down here to update the system, we have to do the same thing. We have to say, here's our new target, and also 0. We don't care about that. And then also when we get the output, we don't care about this component, so we're just going to say get the X component, which is the first component of the output, and that should fix it. Though I think, again, we have the problem here where it's cached. Oh, no, okay. Okay, that looks slightly off. There's something. Oh, that looks nice. That looks real nice. That looks slightly off. It's actually way too responsive. Okay, before we get to this problem, which is a legitimate thing, first let's get the feel right. Because that's like, it's way too tight. I want it to be like, again, more of like a lumbering behemoth. So I think what we need to do here is we want the frequency to be way lower. 0.4, 0.7, 0.5. Maybe that would work. So we're gonna update that. And the trick here, this is the same bug before that bit us, right? The system is already saved in the state. So we can't just update this number. That's gonna do literally nothing if we want 0.4. So one way, at least this one I know, a good way to fix this is I do have, I think this function, I think that's what I called it. Sorry, lib. Yeah, params, that's what I called it. So you can just do that, and we can say 4.7, 0.5. And so slightly wasteful, but whatever, it's a hack. We're just saying for now, update the parameters to that every frame. That's looking a little looser. If I come in closer, it should be. Still not quite right. I think I want more of an overshoot. So I think we want the damping lower. So maybe like that. 0.3 then. So let's try. That looks even tighter than it was before. Maybe, okay, maybe I screwed this up. Let's just, again, hardest part of DragonRuby is knowing when you just gotta throw out the state and actually start the game over. No, this one. I love that bug. I don't know. Something is off about that. Let's see. What's the direction? More live debugging. Thrilling live debugging. So let's see. We're getting the direction. Just want to double check I didn't screw this up. Player position Y minus the boss position Y, player position X minus the boss position X. That's their direction. I believe that's in radians. Update RGBA current frame rate. Yep. Direction T. We get the X value out. That's that. We're using that in their angle. I mean, yeah, that's pretty clearly correct. 4.3.5. Did I totally not copy that down? This is where the Control-C actually would have come in handy, because I totally copied that wrong. I'm glad I was smart enough to add that feature and then not use it like an idiot. I put 4 instead of 0.4, you dummy. Okay. And then actually, okay, let's give this another go. Oh yeah. Now he's like drunk. That's way too loose. Okay, let's so what's the problem here? I think it's mainly, honestly, the fact that it's so slow to respond is not so bad. It's the fact that it overshoots by so much. So let's find like a happy medium. Maybe like 0.6. and here I go immediately not copy pasting things and causing myself pointless grief. That's looking pretty nice. And then I think we'll still have, yeah, we'll still have that bug. We'll get to it. We'll get to it. So, yeah, I kind of like this. It's pretty good. So the, yeah, I mean, you can imagine like if this boss had like, if he was like shooting out of here, right? It'd be kind of cool to have, it's like as I'm moving, it's like chasing me around and the shots are like lagging behind. So I have to like, you know, do something interesting to dodge them. So this kind of like, you know, easy physicality is nice. So again, had some bugs, but all in all, it was just adding like a couple lines of code to get this physicality. So now let's talk about the bug. What the hell's going on there? So maybe you've already thought of it, that rotation wraps around, right? Once you reach maximum rotation, it wraps around back to 0. And that's almost certainly the problem here, because the second order system by default it doesn't have wraparound. It's just an infinite, you know, parameter space. Things can go to negative infinity and positive infinity, which is not how degrees work. So it's actually fairly difficult to solve. I know because I solved it. So the second order system actually has a way to handle wrapping parameter spaces, and it's just an optional parameter when you're initializing it. So after this parameter, we'll give it another parameter, which is the wrapping dimensions. And so we're going to say that the x, I guess x axis wraps around at 2 pi, because that's how rotation works. And then the y-axis we still don't care about. And now I don't know of a clever way to update that, so we are just going to restart the game so that we clear out the bad state, which is here again. And now the problem is fixed. Woo, so we can spin him around forever, and he kind of lags behind us. And so that's it. That's everything I wanted to show you. We've added this physicality to the game, where everything now has this like interesting feel to it. This feel is easily tweakable with parameters. You can use my animation editor to easily play around with those in a visual way, like outside of your game, so you don't have to tweak everything in your actual game code. You can play around in a playground and then copy it in. And that's it. Oh, I said we would test the jolt. We can do that. So before the jolt was literally like kind of teleporting me around. Now that we're using a second order system, we get this like natural behavior where you can actually see I'm like smoothly transitioning. It's no longer a teleport. It's more of like actually like a dash. Like you could implement a nice dash mechanic using this. So another benefit of a second order system is it gives you all this like simple, almost like emergent procedural behavior off of very basic inputs. You don't have to do a lot of math because the system handles all the math for you. So yeah, that's that. And I guess maybe, I don't know if this would be interesting or not, we can look at the diff in Git just to have a sense of like how much we had to change to actually add all of that juice to the game. So here's like the little wiggle loop, adding that. Maybe I can do like a git word diff. It would actually be even better. So you can see like that we just added this position system and had to rename a variable, then swapping out which variables we're updating based on the input. This little bit here is just like updating those second order systems for the player input and the boss direction. And then this is a little charge curve animation here, and using the correct player position, resetting the charge curve, and then changing what values we use to draw to the screen. So yeah, this is basically why I made this library, because it lets you, it really does encapsulate all of the complexity, so you don't have to like sprinkle it throughout your code. Your code looks much cleaner and you can add a lot with relatively few changes. So yeah, I hope this was useful, and you can check out the links in the description for trying it out for yourself.